In section 2.8, we're going to be talking about slope and equations of lines. So the slope of a line is going to be the ratio of the vertical change, which we call the rise, to the horizontal change, the run, between any 2 points on the line. So that means I'm going to take a point here and a point there, x1, y1, and x2, y2. And ratio means fraction, okay? So I'm going to divide them, and I'm going to take rise divided by run. We call this m when we write this into an equation, and hopefully this is a familiar equation to you, but if not, this is how you calculate it. Know this equation. This ratio can come out to be one of 4 different things. We always read a graph from left to right on the x-axis. All right, so if that y value is going up as x gets more positive, then y is getting positive as x gets positive, so that is a positive slope, okay, as 1 goes up, so it rises from left to right. Okay, so that left to right is really important. But if it falls as it goes from left to right, then I have a negative slope. That ratio is going to come out to be negative when I plug in my values for my points. If I have a completely flat line, completely horizontal, y never changes, then I have 0 slope because the change in y is 0, so my ratio is 0 divided by however far I go along the x, doesn't matter, it's still 0. So that's a horizontal line is 0 slope. And then an undefined slope is if I have no change in x, so x2 minus x1 is 0 because they're the same value when it's a vertical line. I can't have a fraction divided by 0, so that's an undefined fraction, so my slope for a vertical line is undefined. In our next examples, we're going to actually find the slope of a line through these 2 points. There's a graph, so the first thing you should do is graph the points, okay? So remember in our coordinate pairs, it's x and then y, and so this will be x1, y1, and then x2, y2. So x is this one and y is this way. Always label your axes if they aren't labeled for you. And so x is going to be -3, 1, 2, 3, and then up 2. So this is my first point. And then the second point is 1, 2, 3, 4, 5 in the x direction, and then up 4, 1, 2, 3, 4. Okay, so just looking at this, I know that it's rising from left to right, so I should come out with a positive ratio when I plug in to my equation. M equals y2 minus y1 over x2 minus x1. So y2 is 4, y1 is 2, x2 is 5, and x1 is -3. So when I simplify this, the top, the numerator, is 4 minus 2 is 2, and then 5 minus -3 is actually 5 plus 3, or 8, which I can then simplify to be 1/4. In our next one, my 2 points, x1, y1, x2, y2, are going to be at -4, 1, 2, 3, 4, and then 0 in the y direction, so here, remember this is x, this is y, and then my second point is at 2 for my x, and then down 4, -4 in the y, and so now I can see that that line is going to have a negative slope, so my ratio had better come out negative. And I'm just going to plug them into my equation. y2 minus y1, change in y, over change in x, is x2 minus x1. x2 is -4, y1 is 0, x2 is 2, and x1 is -4. So when I simplify this, -4 minus 0 is still -4 in the numerator. And then in the denominator, 2 minus -4 is 2 plus 4, which is 6. I can leave the negative, and then 4 and 6 are both divisible by 2. So I divide both the top and the bottom by 2, and I get -2/3 as my slope. Sometimes you'll be asked to compare the slopes of two different lines, okay? They don't actually even have to intersect where you can see them, but as long as two lines have different slopes, they will intersect eventually. And in that case, one line will be steeper than the other, and the steeper line has the slope with the greater absolute value. So that means we don't care about whether it's a positive or a negative slope. We just want to have the bigger number. Okay? So, for example, if one line has a slope of -2 and another line has a slope of 1/8, although 1/8 is greater than -2, because it's positive and -2 is negative, when it comes to steepness, we don't care about the negative sign, we want the absolute value. So the absolute value of -2 is 2. And then the absolute value of 1/8 is still 1/8. And now 2 is bigger than 1/8, and so line 1 is actually steeper. So we can actually say that if lines have the same slope, okay, in which case neither line is steeper, then they will never intersect, and so they must be parallel, okay? So that's a postulate. We don't have to prove it. So two non-vertical lines are parallel if and only if they have the same slope. So that means I can go from two parallel lines have the same slope, and I can say that two lines that have the same slope are parallel because this is biconditional. And additionally, any two vertical lines are parallel because their slope is undefined, so they have the same slope. We can also compare slopes to tell whether lines are perpendicular. In which case, if I have two non-vertical lines, if the product, which means I multiply their slopes together, if that comes out to be -1, then I have perpendicular lines. And it turns out that actually horizontal lines, if I have a perfectly horizontal flat line and a vertical line, those are always perpendicular as well. Those make a 90-degree angle. Just like our x and y axes, they make a 90-degree angle. But any horizontal line and any vertical line are automatically perpendicular. Just a little side note here, if when I multiply two numbers together I get -1, the numbers that I multiplied together are called negative reciprocals, okay? So in that case, slope 1 would be the reciprocal of m2 but with a negative sign. So if m2 was positive to start with, now m1 will be negative. And if m2 was negative to start with, then a negative times negative would make m1 positive. And then that same relationship, if I just solve that for the other variable, m2 is also the negative reciprocal of m1. In this example, we're going to be plotting 6 different points, so we'll start with that. That's our first step. So A is at 0, 6, so that's 1, 2, 3, 4, 5, 6 up on the y-axis. So remember, this is x and that's y. And then B is at 2, 0, so that is B. C is -2, 6, so -2 and then up 6. D is at 0, 1. E is at -6, 5. And F is at -4, 0. So that's our first step, is to plot the points. Now, we're going to look at the lines that we are looking at. So we have line AB, so that connects A and B. We have line CD, here. And we have line EF here. Okay, just based on the picture, it's kind of hard to tell which one is the steepest, if any of them are parallel, especially when you consider I'm doing this with a stylus on an iPad. But we have a way to actually answer these two questions. Okay, so we want to know which lines are parallel, if any, and which line is the steepest. Both of those questions relate to the slope. So for each one of these, we're going to take the slope, and I'm just going to put a subscript here for the slope of line AB, is going to equal, here, this is going to be x1, y1, and then B is going to be x2, y2. So y2 minus y1 over x2 minus x1 becomes 0 minus 6 over 2 minus 0. So I have negative 6 over 2, which is negative 1/3. For line CD, the slope is still going to be the same starting equation. You're going to get very familiar with this. Okay, but C and D, this is x1, y1, x2, y2. So it becomes 1 minus 6 over 0 minus negative 2, which equals negative 5, and then minus a negative number is a positive number, so it's negative 5 halves. I'll make that a little bit clearer. And my third line, EF, x1, y1, x2, y2, and the slope there, y2 minus y1 over x2 minus x1 is 0 minus 5 divided by negative 4 minus negative 6. So that is negative 5 in the top, and then negative 4 minus a negative is plus 6, so negative 4 plus 6 is a positive 2. And now we have enough information to answer our two questions. And so for the first question, which lines are parallel? Well, this and this are the same number, and so the same slope for two different lines means those lines are parallel. So we can say that CD, line CD, our blue line, is parallel to line EF because they have the same slope. To answer which line is the steepest, I need the largest absolute value. So these two, again, have the same. And then I just have to figure out, is 1/3 bigger or is 5 halves bigger? Because all of them have a negative. When I take the absolute value, the negative sign goes away. So 1/3 is about 0.33, right? It's repeating. And then 5 divided by 2 is 2.5. So 5 halves is greater than 1/3. Therefore, actually, there's not a single line that is the steepest, but CD and line EF are the steepest lines. In our next example, we have a line between 2 points, and we want to know the slope of the line, of any line that is perpendicular. So there's several pieces of information here. So a perpendicular slope means that I'm going to be calculating the slope of my known line, and then it is going to be -1 over my original slope, right? So M2 is going to be -1 over M1. So let's start with finding our slope of our first line. So M1 is y2 minus y1 over x2 minus x1, where this is x1, y1, x2, y2. So that becomes -1 minus 5 over 3 minus -2, which equals -6 over 1, or just -6. And so now To find the slope of the line that is perpendicular to that, I plug in -1 over -6. The negatives cancel, and I'm left with just 1/6. In our next example, we have 4 points, and we're going to be looking at 2 different lines, line A and C. So I'm going to do these in 2 different colors, x1, y1, and then C will be x2, y2. And our other line is line VD, so that will be x1, y1, and then D will be x2, y2. And we want to know if they are perpendicular. So we'll start by figuring out the slopes, and then we will see if the slopes match our relationship between perpendicular slopes, as in, are they negative reciprocals? But first things first, we're going to find the slope of line AC. So that is y2 minus y1 over x2 minus x1. So that is 2 minus -4 over 4 minus 1. 2 plus 4 is 6. 4 minus 1 is 3. So that equals 2. And then line BD, my slope is y2 minus y1 over x2 minus x1. When I plug those values in, it is -1 minus 2 over 5 minus -1, which is -3 over 6, which is -1/2 when I simplify these. So now my question is, are these lines perpendicular? Which means that M2 is -1 over M1, and vice versa. M1 is -1 over M2. So if we call this M1 and this M2, okay, as long as one of these equations is satisfied, we don't have to solve for the other one. So we need to see if does -1/2 for M2 equal -1 over M1, which is 2. Those do match, so they are perpendicular. In our next example, we have 2 lines, and for each line we have 2 points, and we want to know which line is steeper. So we have to compare the slopes. So line Q, here's x1, y1, and x2, y2. Let's figure out its slope. So the slope of Q is y2 minus y1 over x2 minus x1. So here x2 is 5, and then x1 is 2, x2 is -4, and then -1 is 3 over -5. And then I'm going to have to look at line T. So x1 and y1 for that point, and then x2 and y2 for that point. The slope of line T, same formula. And now that is 7 minus -1 over 10 minus -2. So this is 8 over 10 plus 2 is 12, which both the numerator and the denominator are divisible by 4, so I'm going to divide both of those by 4 and get 2/3. Now we have to compare them. Steeper means the absolute value of the slope is larger. So for T, that is just 2/3. And then for Q, we don't care about that negative there. It's just going to be 3/5. So the question is, which one is greater? 2/3, if you put this into a calculator, so hopefully you have some idea of where these fractions fall between 0 and 1. But 2 divided by 3 is 0.6 repeating. And then 3 divided by 5 is just 0.6. No repeating, nothing after that. So 0.66 is a little bit bigger than 0.60, okay? And so t is our steeper line. So now we're going to talk about how to write the equation for a line. So this is called a linear equation because it's a line. And we call this first form slope-intercept form because we use the slope and then we use the y-intercept, okay, which is on our graph, this point right here. And so that value of y is b, and we plug those in. Okay, so this is y equals mx plus b, slope-intercept form of a line, and it's the one that is probably the most useful for getting information about the graph right away. Because when we graph a line from slope-intercept form, we first plot my y-intercept, and so if I just have a coordinate system, whatever that b value is, if it's positive, I go up from the origin. If it's negative, I go down from the origin. We already have an example here of it being a positive b, but if b is negative, it can be here. So it's on my y-axis. All right, so that's my first step. And then I'm going to use the slope, rise over run, to plot another point. So in physics, we usually graph time on the horizontal axis, and time always marches forward, okay? We like to run forward because running backwards is dangerous, so we always want to go to the right for our run, and then your rise is either positive or negative, okay? So on this graph, we had a positive rise, so my slope must have been positive, and you can see that on the graph, but I'm again going to graph it with a negative value for my slope so you can see an example. So in this case, if I have some run value, so we'll say maybe this is 1 over 3 but negative, so negative 1 over 3. So I'm going to run 3 and my rise is a negative 1, and so I'm going to count over that many spaces on my axis. So if it's 1 grid square equals 1, then I'll just count squares. You might have to check your scale to see if that's true, but for right now, we can just go with that. So you go run, and then down is your rise, plot my point, and then my third step is to draw a straight line, and if it says sketch, you might look something like what I have, okay, where it's not perfect, all right? If it says graph, you should use a straight edge in order to make it actually a straight line. So in our first example question, we are going to write the equation of a line that is parallel to y equals negative 3x plus 2, and that passes through the point 2, 1. Lots of pieces here. So we know we want to write the equation of the line, which means y equals mx plus b. Okay, so we need to find our slope, and we need to find our intercept. The only pieces we know are that a point on the line, unfortunately it's not our intercept because our x value in that coordinate pair is not 0. So we're going to have to get to that. So the easy thing to figure out is our slope, because in the equation that we already have, negative 3 is the slope, and the plus 2 is the intercept for that line, so we don't care about that intercept. But if it's parallel, then I know that it has to have the same slope. So I know in my equation, I'm going to have y equals negative 3x plus b. It's not going to be 2 again, because I'm looking for something that's parallel, not the same line. Okay, but how do I find that b value? Well, the other piece of information that I have is I know that my new line must go through this point, and that's x and that's y. I can substitute those into my equation, so y equals 1, negative 3 times x is 2, and I'm going to solve for b. I now have an equation, I have an unknown, now I just do some algebra. So 1 is -6 plus b, and I know that can sometimes look very similar in my handwriting, but I'm going to add 6 to both sides, so 7 equals b. Now I know what my intercept is, which means I can plug that in, and y equals, I'm going to go from here, -3x, and now I can substitute in my known value of b plus 7. In our second example, we want to have an equation for line n, which we know is parallel to k, which has this equation, and then it passes through this point. So this is going to be a very similar process. Okay, so we know we want an equation for y equals mx plus b for n. Okay, parallel means I'm going to find the same slope, so that is my m, and I have a point that line n goes through, so I will then plug in that x and that y. So I know that y equals -1/3, and then x plus b. So now let's substitute in those values for x and y. So 2 equals -1/3 times 3, and then plus b, so we're going to solve for that. This is 2, and remember 3 is 3/1, and so 1/3 times 3 is just 1, but there's a negative sign, so that equals -1 plus b. Add 1 to both sides, and 3 equals b. So my final equation is y equals -1/3 x plus 3. We can also write linear equations, again the equation for a line, in the format ax plus by equals c. So x and y are still my x values and my y values for any point on that line, but then the coefficients on a and b and then c are all constant numbers. Okay, so they are real numbers, not imaginary, and both a and b can't be 0, because if they're both 0, then there's no line. So any linear equation I have, I can write it in this form. In order to write it in this form, we're going to start by writing it in either slope-intercept form, or we'll see point-slope form, okay? But then we simplify. So we're going to combine all like terms, and then we're going to collect all of the variable terms on one side of the equation, and all of the constant terms on the other side. So what does that look like? Well, we have an example. Line K has this equation here, and then line J is perpendicular and passes through the point 4, 0, and we want an equation for line J in standard form. Okay? So, we have to go through the same process of identifying slope. So what does the slope equal, and what is our intercept? We need these to get started. So, first things first, y equals mx plus b. What's m? Well, k has a slope of -2, but perpendicular means that m is going to equal -1 over -2. My negatives cancel, so slope is 1/2 for line J. So y equals 1/2 x plus b. Now we have to find b, and we're going to use our x and y values for the points that line J goes through. So y is 0, and then 1/2 of 4 plus b. So 0 equals 1/2 times 4 is 2. Subtract 2 from both sides. So b equals -2. I can now write my equation in y-intercept form. So this is 1/2 x minus 2. And I want to put all of my variables, all of my x's and y's, on one side. Okay? If it's in slope-intercept form already, I can just subtract my whole mx term from both sides. So I'm going to subtract 1/2 x. So now the left side of the equation, and we want to write our x term first. And so we get negative 1/2 x plus y equals negative 2. And now I have ax plus by. There's nothing written in front of y, so my invisible coefficient is a 1. Okay, and then equals just a number, and so in this case, c is negative 2. One more example of writing the equation for a line in standard form, so always pay attention to if it tells you which way it needs to be written. So we want an equation for line M in standard form. So our first question is the slope is what, and then our next question will be what is our intercept, and then we will collect it all in slope-intercept form and rearrange. So the slope, I know that I am going to be using this equation, but oh no, that one's in standard form too. Well, here's the tricky thing. Let's rearrange and solve 5x minus 3y equals 12. And let's solve for y. We're going to go the other way from standard form to slope-intercept form. So I want y by itself, and I'm going to subtract 5x from both sides. So I will have negative 3y equals negative 5x plus 12. And then I'm going to divide both sides by negative 3. So when I do that, I have to divide the entire right-hand side by 3. So negative 5 divided by negative 3 is a positive 5/3 x. And then 12 divided by negative 3 is a negative 4. So we have now line K in slope-intercept form, and we want a perpendicular slope. So I'm going to take this m value, and I'm going to say negative 1 over 5/3 is negative 1 times the reciprocal of that. So it's negative 1 times 3/5. The 1 doesn't do anything, but it becomes negative 3 over 5 is my slope. So I'm going to put that in here, so that equals negative 3/5. And now I have to find b. I'm going to use this point. So y is 1 equals m, negative 3/5. X is 3 plus b. All right, simplifying that, I get 1 equals negative 9/5 plus b. I'm going to add 9/5 to both sides, and I get 1 plus 9/5 equals b. Well, I can't add those because I need like denominators, but 1 is just 5/5, okay? So I can now add them, so that equals 14/5.